Hello. For this project in mechanical system design, we will be talking about a renewable source of energy, aka the wind turbine. Our group members consist of Ryan, Hamad, Ghazi, and Khalid. The concept of renewable energy is touched upon by the greatest engineering feats of the 21st century. The goal is to create a method to utilize renewable energy via wind. The horizontal axis wind turbine is split into three components: the rotor, the generator, and the surrounding structure. The rotor, which approximately equates to a third of the total wind turbine cost, includes the blades for converting wind energy to low speed rotational energy. The generator, which equates to almost half of the total wind turbine cost, includes the electrical generator, the controls for the electronics, and some sort of gearbox, which is adjustable speed drive for continuously variable transmission components, converting the low speed income rotational into high speed rotational suitable for generating electricity. The last part is the surrounding structure, which equates to almost a quarter of the total wind turbine costs, which is like the towder, the rotor yaw mechanism. Since our renewable source of energy is wind, which is unlimited, we will use this to power the blades to spin a shaft connected to a generator to form electricity. Our main focus for this project dealt with the aerodynamicness of the blades for the wind turbine and how they will efficiently transfer energy into the generator as electricity. There are two different main types of turbines that are used throughout society, and the one we will be focusing on today is the horizontal axis wind turbine. Since our main focus today is of the aerodynamicness of each individual blade, we will talk about the aerofoil parameters for each blade. Here in the first figure, you can see the names of each part of the blade, as well as the name of the important components of the blade. The second diagram is a hand-drawn free body diagram of the aerofoil. Here you can see the forces that act upon the blade, including the airflow, the lifting force, the drag force, and the pitching moment. This diagram illustrates the airflow of the wind being pushed over the blade of the turbine, creating all the forces and moments that take part into the turbine. Through computer-aided design software, we created our own turbine blade, which we proved statistically to be incredibly efficient for producing a renewable source of energy by converting the wind into electricity. Finding the key stress points in an engineering system is important. Knowing which parts and where in the system is most likely to fail due to static and dynamic stress, engineers can compensate for these points to prevent catastrophic failures. The key point of static failure occurs a fourth of the way down the blade closest to the center point about which the blades rotate. This could cause a blade to fall off and go flying, or simply to flop over, while causing the centripetal force to offset the balance of the entire system. The key point for dynamic failure would occur either in the rotational bearings that connect the spinning blades to the shaft to create electricity, or the dynamic failure could occur in the gearbox drive, which the movement of the blades rotate the gears within the system in the shaft to create and generate electricity. In our written report, the details are further analyzed. The importance of renewable energy sources are ever more increasing. As we continue to use non-renewable sources of energy, such as coal and oil, we need to start looking to the future for cleaner and better sources to power our homes and factories. By tapping into clean energy sources, we can reduce the pollution and reliably produce a low-cost source of energy, which will help our planet recover in a better way.